Today I will be talking about physics. The problem with physics is that to know physics you have to know what calculus is, which is pretty bad because, you know, calculus. And to know calculus you have to know what the limit and derivative are. Okay, let's start with the derivative first, and let me give you an example of a derivative. Let's say you own a stock. No? Yes. Let's assume that your stock gets updated every single microsecond and you want to find how much it increases or decreases at a specific point in time. But the problem is, you can't find a slope when a line is curving. The line has to be linear if you're going to find a slope. So how do you find a slope? Alright, let's pick a point like x equals 1 on our stock, and then pick another point like x equals 2. Then we'll draw a line in between the two, just a regular linear line. And then we'll make x equals 2 approach x equals 1. As the point at x equals 2 approaches x equals 1, we are getting closer and closer to an instantaneous change. Now, for any of you people who have already taken calculus, getting closer and closer to instantaneous change sounds a lot like something you've already learned of, a limit. So if I Google what a limit is, I will probably get a definition as a point or value that a sequence, function, or sum of a series can be made to approach progressively until it is as close to the point or value as desired. And that is basically what we did in that stock problem. We approached 1 from the point x equals 2. That's what a limit is. The line between the 2 points was a derivative. It was instantaneous change. Let's try a physics-based example now. Let's say I have a car moving at a constant speed, so its graph would look like this. And it's linear, so its slope is constant. It always has the same slope no matter what. Now, if I plot average velocity over time, delta x over delta t, I get a straight line. Let's say there's another car driving according to the equation y equals x squared. And I don't have a constant slope, so I'll never get the same slope twice because the change in the line is not always the same. When I try to get average velocity, I get incorrect line. But I can get a more accurate average velocity if I use infinitely small intervals to calculate the average velocity. So to get a derivative, I will use the power rule, where we can take the power number and multiply it by x while subtracting 1 from the power. So my equation y equals x squared would have a derivative of y equals 2x. So if I wanted to find my velocity in meters per second after 10 seconds, I would plug in 10 for x and get the value of 20 meters per second. Now you know what a limit and derivative are, but don't worry, it gets worse.